Welcome, dear students, to Standard 7 Maths. This is teacher Sharon De Silva, and we are discussing chapter Indices. Division of indices with the same base. Now, if you see, you by now you know that this is called as the base. Number 6 is the base over here, and number 4 is the par or the index. Number 4 is the par. So, this is 6 raised to 4 divided by 6 raised to 2. If you see, in both the cases, the base is the same. So we simplify this in this manner. 6 raised to 4 means 6 multiplied 4 times, and 6 raised to 2 means 6 multiplied 2 times. Now if you can see, this 6 and this 6, this 6 gets cancelled, and we are left with 6 multiplied by 6 means 6 raised to 2. So the answer is 6 raised to 2. If you see, this 2 I can also get by subtracting 2 from 4. So that is another way. 6 raised to 4 divided by 6 raised to 2 is 6 raised to 4 minus 2, which is 6 square. Now next example. Over here, minus 2 raised to 5 divided by minus 2 raised to 3. Now the base is exactly the same. Now my dear students, if the base over here was positive, then the base is not same. We have to look at the signs also. Same base means same sign as well. So we have minus 2 raised to 5 upon minus 2 raised to 3. This is 5 times, this is price. So this 3 times 2 gets cancelled, and we are left with minus 2 raised to 2. Again, this would be 5 minus 3, which is 2. So this is your answer. Now we are going to look at certain laws of indices. My dear students, laws or rules of indices help us to solve sums related to indices. So these are of extreme importance. The meaning of a raised to 0. If a is not equal to 0, then a raised to m upon a raised to m is equal to 1. Also, a raised to m upon a raised to m will be a raised to m minus m, which is equal to a raised to 0. Now, my dear students, this we can do when a, the base, is not equal to 0. Now I have same base, and base is raised to a par. Now the par is also the same. Okay. We know that when we have same par and same base, this will get cancelled and we'll get the answer as 1, which also says that this is a law of indices, a raised to m upon a raised to m. When the bases are divided, the pars are subtracted. This is a law of indices. So I have a raised to m minus m. M minus m would be 0. So a raised to 0. And I know that this, the value is 1. So a raised to 0, the value is 1. For this, you can take any example. Say 9 upon 13. A can be any. It can be a fraction, it can be a number, it can be a positive number, negative number. So a, but it should not be 0. So a, in this case, in this example, is a fraction, 9 upon 13. So 9 upon 13 raised to 0, the answer is 1. Another such example. In this case, my a is a negative fraction. So I have negative 353 upon 475, the whole raised to 0. The answer in this case is also 1. So a can be anything. A raised to 0 is always 1. You need to remember this. Now next law, my dear students, is something called as multiplicative inverse. The meaning of a raised to minus m. A raised to minus m into 1. Now 1 in the previous case can be a raised to m, the same, upon a raised to m. Now we know that when the bases are multiplied, the powers are added. So I have a raised to minus m plus this m, and upon a raised to m remains the same. Now a raised to minus m plus m means a raised to 0, right? So I have a raised to 0 upon a raised to m. And we know that the value of a raised to 0 is 1. So I have 1 upon a raised to m. So whenever I have such a particular number, a raised to minus m, it also means that which is equal to 1 upon a raised to m. What happens is, what is the difference when this particular number goes into the denominator? The negative sign of the power is eliminated. And if I have this case, I have 1 upon a raised to m, and I want to bring this the reverse. I want to bring this in the numerator. Then my power will get the negative sign. So a raised to minus 1 is the multiplicative inverse of a. Suppose over here, instead of m, I had 1. So this would be a raised to minus 1. It will be equal to 1 upon a raised to 1. But we don't write this one. If 1 does not have a negative sign, then we don't write that. So that will just be a. Thus, the multiplicative inverse of 5 upon 3 is 3 upon 5. Just interchange the numerator to denominator and denominator to numerator. So 5 upon 3 raised to minus 1. Its multiplicative inverse will be 3 upon 5. And what will happen to the power? The power is there, but since it is positive 1, we don't write that positive 1. Now see, find the multiplicative or find the reciprocal of minus 7 raised to 2. So here it is solved. Minus 7 raised to 2 would be 1 upon minus 7 the whole raised to 2. Now if we try to solve this further, this is how we get the answer. You need not worry about these sums. We will solve them a little later. These are just examples. Just have a look at them. 2 upon 7 raised to 7. The reciprocal or the inverse of this would be 7 upon 2 raised to 7. See, if it is a fraction, it's the numerator goes to denominator, denominator comes to numerator, the power remains the same. Minus 3 upon 4 raised to 34 will be 4 upon minus 3 raised to 34, and we never have minus in the denominator, so we bring that to the numerator. So we have minus 4 upon 3 raised to 34. These are a few examples. Next particular law. If a is not equal to 0 and b is not equal to 0 and m is a positive integer, then a upon b the whole raised to minus m is b upon a the whole raised to m. Just now what we discussed. So let us consider 4 upon 7 the whole raised to minus 3. This is our particular number. So how do I simplify it and how do I solve this? This would be 1 upon, why am I taking 1 upon? Because this is, the power is negative. So I have 1 upon 4 upon 7 into 4 upon 7 into 4 upon 7. Why have I taken thrice? Because my power is 3. And this 4 into 4 into 4, the cube of 4 is 64 and the cube of 7 is 343. And this is 1 upon 64 upon 343. And we know that we cannot keep the sum this way. So this particular denominator goes to numerator and numerator will stay as denominator, and I have 343 upon 64. But this 343, my dear students, is cube of 7. So 7, and this is cube of 4. So 7 upon 4, the whole cube. Now if you look at the original sum, I have 4 upon 7. And what has happened is the numbers have interchanged their position. And this particular power which had negative sign has now become positive sign and the same power. So this is another law of indices. Some examples shown over here. 4 upon 7 raised to minus 2 will become 7 upon 4 raised to 2. Now if you are told to just write simplify, then this is your answer. But if you are told to evaluate, means find the value, then you need to solve this further. So this will become 7 raised to 2, 4 raised to 2, 7 square is 49 and 4 square is 16. So then this will be your answer. Same way, next particular sum, minus 3 upon 8 the whole raised to minus 3. What will happen? The numbers will interchange their position and you will get 8 upon minus 3 the whole raised to 3. Now if you are asked to solve this further, then you will get this 8 will be raised to 3 minus 3 raised to 3. So this is how you solve, and this again the sign will go in the numerator and you will get 512 upon minus 512 upon 27. Next law, if a is a rational number, a is not equal to 0 and m and n are positive integers, then a raised to m upon a raised to n is equal to a raised to m minus n. Now if you pay attention, a is not equal to 0. That means it is a number. It can be positive, it can be negative. And m and n in this case are positive integers only. And both are different. If you see, this is m and this is n. They are not the same. Then when the bases are the same and they are divided, what happened to the powers? What happens? The powers are subtracted. So this is the next law. When the bases are divided, the powers are subtracted. An example is shown over here. See, the base is the same, but the power is different. In the first case, m is smaller and n is bigger. M is smaller, n is bigger. So what will I have? When I simplify this, 4 times 3, 6 times 3, 4 threes will get cancelled. I'll be left with 2 threes. So that is 1 upon 3 raised to 2. This I can also write as, using this law, using this I can also write this as 3 raised to 4 minus 6. Now 4 is smaller, hence I will be left with 3 raised to minus 2. My dear students, this 3 raised to minus 2 and 1 upon 3 raised to 2, both are the same. This is the same. Next example, 3 upon 5. Now this is my a. In this case, my a is a fraction. Just a minute. Yes. In this case, my a is a fraction. What is that fraction? 3 upon 5. And this is my m divided by 3 upon 5 raised to, this is my n. So I have simplified this and I am left with 1 upon 3 raised to 5. How many times it is multiplied? Twice. So 3 upon 5 raised to 3. This is simplification. Now if I am going to use the law, then this is how I am going to solve. M minus n. So m 2 minus 5, which is minus 3. Again this and this is the same. Now just have a look at these examples. Now that particular law which we discussed just now, this law, my dear students, is simplified further in these examples. Instead of a, now I have taken x. X upon x raised to m upon x raised to n will be x raised to m minus n. But in first case, m is greater than n. So what will happen? See, example 3 raised to 8 upon 3 raised to 6. So 8 is greater than 6, that is m is greater than n. So I will be left with 3 raised to 8 minus 6, which is 3 raised to 2. The answer is 9. Another example, 5 upon 4 the whole raised to 8 divided by 5 upon 4 the whole raised to 5. 8 is greater than 5. So my answer is 5 upon 4. 8 raised to 8 minus 5. 8 minus 5 is 3. So 5 upon 4 raised to 3. Which means the whole raised to 3 means 5 raised to 3 upon 4 raised to 3. So 5 raised to 3, 125. 4 raised to 3, 64. This is my answer. So this was the first case. Now the second case, my dear students, where m is smaller. Just now what we discussed. See these sums? Over here, m was smaller. So in that case, what will happen? X raised to m upon x raised to n would be 1 upon x raised to n minus m, where m is smaller. So I have 4 raised to 4 upon 4 raised to 7. If you see, my m is smaller. So they have shown 1 upon 4 raised to 7 minus 4, which is 1 upon 4 raised to 3. So 1 upon 64. This they have done, my dear students. This is shown to eliminate the negative sign. One more example. 2 upon 5 raised to 3 divided by 2 upon 5 raised to 5. So I have 2 upon 5 raised to 3 upon 2 upon 5 raised to 5, which is 1 upon 2 upon 5 raised to bigger number minus smaller number. I'll be left with this. And this, my dear students, means 5 upon 2 raised to 2. So 25 upon 4. We can also write this in this manner. See, the answer is the same. So this would be 3 raised to 4 upon 3 raised to 6. We can simplify this and we get 1 upon 3 raised to 2. So either ways, this is also same and this is also same. Next, observe what happens if the base is minus 1 and the index is a whole number. See, the base is minus 1, index is a whole number. Minus 1 raised to 6. So I have minus 1 multiplied how many times? 6 times. Now what I have done is I have taken pairs. This is one pair, this is second pair and third pair. And we know that negative multiplied by negative is positive. Negative multiplied by negative, positive. Negative multiplied by negative, positive. So what am I left with? Positive 1 multiplied by positive 1 multiplied by positive 1. So the answer is positive 1. Now look at next example. Negative 1 multiplied how many times? 5 times. So again this is 5 times. This is one pair. This is one pair. And this negative 1 is not in a pair. It is single. So this pair gives me positive 1. This pair gives me positive 1. But this is singular. So I have to write it as it is. So I am left with positive 1 into positive 1, which is positive 1. And positive 1 into negative 1 gives me negative 1. So now what is my conclusion on the basis of this? If m is an even number, then negative 1 raised to m. If m is an even number, 6 is an even number, then negative 1 raised to that number gives me positive 1. And if m is odd number, see this 5 is odd number, then negative 1 raised to that number gives me a negative 1. So a few more examples. Negative 1 raised to 6. Now 6 is even. So my answer will be 1. Negative 1 raised to 9. 9 is odd. So my answer will be minus 1. Similarly, if I have negative 3, instead of 1, if I have negative 3 raised to 4. Now 4 is even. So what will I be left with? The same number without the negative sign. So 3 raised to 4. And if I am asked to simplify it further, this is how I will simplify it. Same way, next example, negative 2 raised to 5. Now 5 is odd. Therefore, what will I be left with? Negative sign and 2 raised to 5. And if I am asked to solve it further, This is how I'm going to solve along with the negative sign, and the final answer will have negative sign because my pa was odd. My dear students, we stop here. We will meet in the next video. Till then, have a nice day. Thank you for watching.